Okay, we're now going to look at the second type of sorting algorithm, and that is shuttle sort. Okay, so like I did with the bubble sort, I'm going to write the numbers in vertically in a column. Okay, so once again we are going to put these numbers 5, 4, 7, 2, 3 into ascending order. Okay, and how shuttle sort works is that it first looks at the first two numbers in the list. Okay, so we box them off, and that's going to be my first comparison. Now 4 and 5 and 4, need to be swapped around. So I wrote 4, 5, 7. Okay. So now I'm going to be, in my second pass, going to be looking at 4, 5 and 7. First off, however, I consider 5 and 7. So I put a box around 5 and 7 to show that that is what I'm comparing next. Now 5 and 7 are in the correct order. Okay, so I can write 4, 5, 7, just as last time. And now I'm going to be looking to include the 2. Okay, so I drop a level down. I'm now going to compare the 7 and the 2. That is where it gets a little bit more interesting. Oh, managed to delete the line. There we are. Okay, now 7 and 2 I know will need a swap. Okay, so 2 is going to be swapped with 7. However, shuttle sort allows us to then compare the 2 with the next number above. Okay, so I'm now going to compare the 2 with the 5, and I know I'm going to need to swap there as well. So I'm also going to need to compare the 2 with the 4. Okay, to make sure it's in the correct position. 2 and 4 also need to be swapped. So 2, in effect, has been pushed to the top of the list. Just like in bubble sort, how the largest number is pushed to the bottom of the list, in shuttle sort, the smallest number is pushed to the top of the list. Okay, so I can now include 3. Okay, so now I've made room, and I am going to be comparing 7 and 3. Now 3 will need to be swapped with 7, and shuttle sort allows me to now compare the 3 with the 5, and there's going to be a swap there, so I'm going to need to compare the 3 with the 4. Okay, and there's going to be a swap there as well, so I also need to compare with the 2. Now we keep on needing to compare the 3 with the 5, with the 4, and then the 2 to make sure that the 3 is getting put in the correct position. Okay, you can't leave 2 out of being compared with. Okay, because the computer is an idiot. Okay, it's not quite sure whether the 2 or the 3 or the 4 will be in the correct position. So I can now write my next line as 2, 3, 4, 5, 7. Okay, and that is it. Okay, we also need to have counted the comparisons as we go, and the number of swaps. With shuttle sort, this is a relatively easy thing to do. I'll just change the colour to green. Okay, so here we can see in the red box we made one comparison in that first pass, and we made one swap. Okay, the 5 and the 4, swapped. Then we've got the 5 and the 7 in the second pass. That was one comparison. We didn't compare any other numbers. Okay, and the 5 and the 7 were in the correct order, so there was no swaps. In the third pass, however, we compared the 7 with the 2, then we compared the 2 with the 5, and then the 2 with the 4, so we made 3 comparisons. And we swapped the 2 with the 7, the 2 with the 5, and the 2 with the 4. So we made 3 swaps. In the final pass, we compared the 3 with the 7, the 3 with the 5, the 3 with the 4, and the 3 with the 2. So we made 4 comparisons. We swapped the 3 and the 7, swapped the 3 and the 5, swapped the 3 and the 4, so we made 3 swaps in total. Okay, we didn't swap the 2 and the 3. So in total, okay, we've got 1, 2, 5, 9 comparisons, okay, and 1, 4, 5, 6, 7 swaps. Okay, so if you compare that with the number of comparisons we needed for bubble sort, we actually needed 10 comparisons. Okay, so more computing time. So for this example, shuttle sort has proved itself to be quicker.